All right, so now we're on to multiplying and dividing monomials. So if we look at number 1, we have k to the 8th power times k. And if you don't see an exponent, that means it's to the first power. So when you're multiplying exponents, when you're multiplying the same base, you look at the exponents and you add them. So that would be k to the 8 plus 1, or k to the 9th power. Final answer. Let's look at number 5. Oops. All right, number 5 says 4r to the 4th times a negative 4r to the 3rd. So I'm going to rearrange this. I've got 4 times negative 4, r to the 4th times r to the 3rd. So I'm using the commutative property of multiplication there, just so it makes it a little easier for me if I have my like bases beside one another. Now I've got a 4 times a negative 4, which would be a negative 16. Then I have an r that's the same base. So I'm multiplying, I'm going to add their exponents, 4 plus 3, which would be 7. So negative 16 r to the 7th power. Okay, so now I'm looking at number 11. Again, I'm going to look at these numerical coefficients. So if I have a negative 11 times a negative 5, that's going to be a positive 55. Then I have w to the 4th power times w to the 3rd power. So I'm going to add those exponents. And then I have an x to the 4th. So my final answer is going to be 55 w to the 7th x to the 4th. Looking at number 13, when you have the same base, and here we do have g, so when you have g and g in the denominator, you take the exponents and you subtract them. So this becomes g to the 15 minus 7, or g to the 8th. Oops, don't know what happened. G to the 8th. Looking at number 17, that would be the same base of n. So we have n to the 19 minus 11, which would be n to the 8th. I want to look at number 14 now because we have coefficients 18 over 9, and then we have v to the 5th over v. So I like to split this up into two fractions, the numerical and the variable. Now, the first fraction, 18 over 9, is 18 divided by 9, or just 2. The second one would be v to the 5th minus 1. So that ends up equaling 2v to the 4th.